So Thermino HP. So we've got, at the moment, we've only got 3 manufacturers that we really are dealing with. That is going to change coming up. So I'm just going to stick with our current product that we have released in the field. Once the new product's been released, you can come back on just for a refresher if you want, just to have a look at it. But I don't want to muddy the waters too much at the moment, so we'll stick to what we have. So Thermino HP low temp. So that's, if you ever get one of these, it'll be a Thermino HP-DN or an SG. So that's a Daikin or a Samsung. So its main purpose is to provide domestic hot water with the low temperature heat pump as a primary heat source. But that heat pump, it might only be able to achieve a 55-degree flow temperature. So if you think back to the previous module 2, we need a 65-degree flow temperature. What will happen is, after 45 minutes, the heat battery will recognise it's not up to temperature, and then it will bring on its internal element to then boost it. So if you've got a 55-degree flow temp and it's running, you're essentially preheating that battery up to 55 degrees. The element will kick in and bring it up to temperature the rest of the way. Okay. One thing to note is these products aren't intended to be used with PV systems as well. So just remember that. We can fit it with the high temperature Daikin, the HHT. So just one thing to bear in mind, if the heat pump's able to achieve that 65-degree flow temperature, like they claim, you can remove link 3, and that will disable that 45-minute time delay. Okay, so link 3 in this case has got different functionality. So it enables that element backup, or it disables it for these units. So there's our 3 manufacturers there: Samsung, Daikin, and also Valiant. Valiant is a high temperature heat pump, so we'll concentrate on Daikin and Samsung for the moment. We'll talk about Valiant later. Not much change there. Your capacities and things like that. So again, not much change. If you're ever working with a Daikin or a Samsung, it will come with one of these accessory kits. So this is all electrical stuff, relay interface, back box, cables, things like that. You can request these parts from us. So that's your tempering valve, expansion vessel, a water conditioner if need be, Tektite elbows, a T-piece. You know, you're probably going to use your own stuff, pipework fittings for that. So back to mechanical connections. The Daikin and Samsung models, cold water in, hot water out, then flow in, return out. So that's how it's always going to be for these models. When we change to a Valiant, it changes again, opposite connections for those heat exchangers. Okay, just remember that. But the Valiant is compatible to work with PV, which is the Thermino HP PV-VT. So the pipework connections then change back again. I never designed it. This is what we have. Going forward with the new product, we will have just single, one pipe for every application, basically. Whereas this is what we have at the moment. So why it's like this just now is our controller has basically got its set points, and the way the unit's discharging and recharging, that's how the controller recognises it from top to bottom or bottom to top. With the new product we're going to be releasing, we're going to have the same connections for all the units, but it's going to be a different controller basically, and that controller will be able to recognise the different set points, but all by itself, so that you won't have to figure all this out. Yes. Oh, sorry, you had your hand up there, George. You're waving to someone.
Yeah, it was just a postman.
Ah, right, okay, cool. So yeah, that's again, feel like I'm just kind of broken record here. Just keep checking your manual if you come across different units you're used to working with. So yeah, Dakin systems, the most important thing for the heat pumps I've noticed since working with them is the flow rates. So yeah, the heat batteries, they do have that pressure drop. So again, your 150s, they still have that flow rate situation. But if you're getting any flow issues, you will have to have your auto bypass fitted there to take it up, the slack, because the heat battery can only take in so much at one time. So that's why we say we only go up to is that 12 kilowatt? 12 kilowatt heat pump. There are we. Yeah. Samsung 12, yeah. 12 kilowatt, because we start going higher than that for your flow rates. You know, a lot of that flow is going round about your bypass, and not a lot of it's getting put into the battery itself. So I think for a 12 kilowatt, what you have, about 27 litres per minute, something like that, 27, 30. But it's just something to bear in mind. I mean, the amount of times I've been to a job and that auto bypass has been fully open it's ridiculous. So really, the heat pump gets up to temperature, starts short cycling, and no heat starts going to your battery. So it's just, yeah, it's all about just commissioning and stuff. So when it comes to electrical requirements, this is what you get in the manual. Quite a lot of wording. There's not a lot of diagrams. So this is why we've done this. So the booster signal wiring, heat pump sensor cable wiring, and there's a little bit of rewiring done in the hydro box, hydro module. There's your link 3 functionality there as well. So that's on the same page as the manual. So let's looking at Dakin wiring. Booster signal wiring from the heat pump goes into terminals 1 and 2. Your control circuit is 3 and 4. So let's see how that looks. So we'll start with the booster signal wiring. So that goes up to X13A, which is at the top there. So that's already got the plug here. You plug it in up here, and then you run that down to your relay interface box into the trigger input. All right, so from X13A, you run your 2 core into the trigger input terminals. So from C1 and N01, you run another 2 core into terminals 1 and 2 here. And that is pretty much how you do it. Can anyone tell if there's a fault going on there with the wiring?
It's in C2, isn't it?
Yeah, exactly. So, but yeah, that's how you do your the booster signal wiring. There's your link 3 again, element. 45-minute time delay. The heat pump sensor cable in is a bit easier. You connect the cable to X9A, which is here. One thing I've noticed is, when a installer was having a fault, they were getting a tank sensor temperature error. And that is because, I don't know if this came from the factory or this was done on site by mistake, but this plug fits perfectly into that plug. So what the installer did was they plugged X9A into X22 by mistake. And obviously it was creating an issue. So swap them round, no problem. So you basically run it from X9A into terminals 3 and 4. And that's your control circuit. So the battery can communicate with the heat pump. Well, we'll talk about communication in a minute. And just remember to put a jumping wire in between 10 and 11A on the terminals up here. What that does is it disables the element, the booster element for the heat pump, and it prioritizes our third-party element, if you like. I've not got any pictures for the Samsung, unfortunately, so I'll just have to talk you through this. Again, you've got your pipework schematic there, so it's fine. So the booster signal wire, it's the same deal. You know, from the heat battery, terminals 1 and 2 goes into N01 and C1 of the relay box. and from the trigger input AC terminals, you run another 2-core, pardon me, and you wire that into the heater terminals L and N of the MIM. Okay. For the tank sensor side of things, you get the Samsung tank sensor supplied, cut the file off the end, strip the wires, and plug it into T3 and T4, and then obviously run that back to your MIM control circuit, and that's how you do the Samsung. Oh.
So that's reading a resistance then, T3, T4.
Basically, yeah.
It's saying that. So can you not do that with a boiler? This is in the Samsung controller, is it?
Yeah, so this is a Samsung. So what we've got here is you've got 3 resistors. So what will happen is when the heat battery is up to temperature, it'll be sending a fixed value resistance
to their controller.
to their controller, which is going to be about 77 degrees. When there's a demand, that fixed value then changes to 40.
Okay.
So if that's all you're ever going to see. You won't see that variable change in temp. So if you're
it's just a method of controlling it.
Basic, yeah. I mean that might change going forward. I know we've been working. The engineers have been working with something that's a 4th temperature sensor that we fit in our dry pocket.
Okay.
And essentially that's going to give you that variable temperature reading.
Yep.
But they're still figuring it out where exactly in that temperature string they're getting the right temperature. So it's something that they're working on. It's just not something we've released. So this is what we have at the moment. All right.
Unless you average the 3 and give it out at that sort of thing.
Pardon me?
If you average the 3, your 3 temperature sensors, and then give that out as a reference.
Yeah, I mean they're trying to. Obviously, you've got to get the right resistor to match what the heat pump can recognise as well.
Yeah.
So going forward, we're going to have, I think, 13 or 15 heat pump manufacturers under our belt with this new product we're talking about releasing. So that means, like, the engineers have just got a lot of work to try and work with the manufacturers to get the right settings. But it's all about the sweet spot as well. So we've got to get the right resistor to work with that heat pump, but we need to find out what the sweet spot is inside the battery to send the right signal back to the heat pump.
I know.
So
this is why there's engineers, and this is why I'm a plumber. So
yeah. But this is what they've engineered, is basically this sort of workaround just now. So the variant, standard variant, as I call it, again, you've got your resistor set up here. So again, 2 fixed values. But we've got an electric override switch for the variant. We've got your control circuit. So you run your 2-core back to SP1, 1 and 2, back to your heat pump interface. But you've also got an override switch if there's a heat pump failure for any reason. So the customer's got a bit more functionality. Again, 2 separate 2 cores in case there's any interference with the two sides of things. Again, you've got your standard variant here. You've got your PV version there. Again, it's fitted with a 4-core, which you wire back to your eddy, and you keep that charging link in place. It's just like wiring the IPV that we done earlier, and you just run your 3 and 4 back to your heat pump interface, SP1 and 2. That's it. There's not much to it. One thing to remember is you have to keep link 3 fitted with the variants. Don't remove that. There's no 45-minute time delay for the element to come on. There's no requirement because it's a high temperature heat pump, so you can achieve the flow temperatures, but you have to keep link 3 fitted. Okay, don't remove it. And that's just a basic kind of wiring schematic. You've got your switch for your volt-free signal for the element, and you just wire your 2-core back to SP1, 1 and 2. Another schematic. So that, yeah, this control circuit logic. So really 2 switches demand or satisfy call to heat pump. So the demand resistors send a fixed resistance value to the heat pump interface, which relates to the temperature on the heat pump display. For example, when there's a demand, it'll be 40 degrees. The satisfied resistor will send a fixed resistance as well, which will equate to about 70. So you only get the two. So it's basically, think of that like a cylinder stat, like off and on. You know, this is just straight for the manual. You've got your heat pump settings there. So just reference that when you're working on it. Same with the Valiant as well, from the Sensible Comfort. Thermino -DN, after 45 minutes, the element LED will be illuminated, then it'll charge, get up to temperature. You might be lucky, it just depends on the conditions outside, what the heat pump can actually achieve. Oh, yeah. Your PV version of the Valiant, again, it's going to be looking for solar. So that element LED will be illuminated more often than not. Same rules apply though. The heat pump will charge it up to 85% and it'll allow the last 15% to be charged from the element, whether it's PV or from grid. So, bit of advice for your customers. Your standard Valiant, that element LED will be off all the time unless you've enabled that volt-free element control circuit. So again, if that's on and you've got the standard Valiant HP-VT, you know there's a problem with the control circuit for the element. You get your flashing lights to get a full charge. Yeah, there's the same thing as the previous ones, guys. There's not much more to talk about the fault finding.